Okay, we're going to go to our class page, go to modules. And then we are doing 3.3, the unit circle. So while you are getting there and you're clicking to get started, I'm going to grab some water real quick. All right, so when you open it, it'll look like this. Oh, I'm sleepy today. Okay. So I'll give you a little entrance speech. If we had been in school in a normal year where I was allowed to pass out things and we were allowed to share things like highlighters, everybody would get a paper plate. So those white paper plates that don't really hold much food, they're not really good for much else, but they are good for making a unit circle. You would get that. You would get a pink, yellow, and blue highlighter. You would get 3 triangles that were cut out that we would use to help us make lines on our circles that are at certain angles. And so it would be like a art class as well as a math class for the day. So I was thinking, how can I do this where students still have an understanding what a unit circle is, where they build it themselves, but digital this time. So that was my goal. I think I have succeeded. I know yesterday's class learned a lot of different technology tips. So maybe you'll learn some of that today too. Like, so maybe you won't learn all math. It'll be something not math as well. All right. So before we do this, you will need to know the following things. You need to know how to click and drag boxes, as well as text box, copy and paste. Remember, you can always like right click something. So select something and right click it to copy and paste. We're going to talk about how to reflect an object by selecting that object. We're going to talk about how to draw a line and how to group things. But we will walk through that together. So you don't have to stress, like, I don't know how to do those things. That's okay. We're going to do them together. Just remember that we will. All right. So the first thing that we are going to talk about is the special right triangle. So the one thing I asked of you last week was to make sure to at least complete the special right triangles video. Even if you're a little late or behind on some of the other work, hopefully you have seen the special rights triangles, or you remember them a little bit from geometry, because they are a repeat of geometry. All right. So this is not the one you guys have. Give me just a second. I'm going to stop sharing to find the right one. All right, I need feedback on, I'm sharing, sorry, full sentences, I know. On the versions that you guys have just opened, if you just opened it for the first time, do you have orange squares on this page? Yes or no? No. So I apparently edited the wrong one, but that's okay because it's actually what I've got here and everything will work out fine. All right. So what we're going to look at is 30, 60, 90 triangles. So these are actually the same triangles. They're just in a different direction. And then we're going to talk about the 45, 45, 90. So on a 30, 60, 90, let's make that font bigger there. On a 30, 60, 90 triangle, you have what's called a short leg, a long leg, and a hypotenuse. And they're all across from those angles. So the little angles up here, the short leg's across from it. The long leg is across from the 60-degree angle, and then the hypotenuse is across from the 90-degree. The short leg is known as X, some number X. And there's ratios that make these proportionate always. So we have X. Then the ratio says that the long leg will be X square root of 3. So here's how I insert a square root. I go down I go to insert, special characters, and then I type in the search bar square root. So anytime, if you've noticed on any of those guided notes, I've had you copy and paste those symbols. That's where I get it from. So from here on out, every time I do a square root, I will probably just copy and paste that square root. But the first time that I grab it from special characters. Okay, and the hypotenuse is 2 times whatever the short leg is. So it's twice the width of the short leg. So in our example given, our hypotenuse is 1. If our hypotenuse is 1, what must the short leg be? Yeah, 1/2. It has to be half of the hypotenuse. So the short leg must be 1/2. So I just added a text box there. So if you want to see the algebra behind that, the hypotenuse is equal to 1, and that equals 2x. So 1/2 equals x. Okay, what about for the long leg? The long leg would have to be 1/2 times square root of 3. And so I would just write that as square root of 3 over 2. Okay, it is usually written as square root of 3 over 2 this way, but since we're on technology, we'll be all right typing it that way, okay? So insert another box here. Make it a little smaller. Okay, so all I've done so far is found what the length of the short side and the long side would be using the ratios for 30, 60, 90s. Okay, that's why these are called special right triangles. They're very common to use. I'm trying to take a minute to let people get this down. Remember, I will be sharing this video at the end for people who miss class. And for those of you that are here, I can also share the link with you at the end after you submit yours. Okay. If I look at the pink triangle, we talked about it being the same as this because the hypotenuse is 1. So the short leg is still going to be 1/2, but now it's going to be the height instead of the width of the triangle. And then the length, the long leg, is still going to be square root of 3/2. Okay. And then we'll do this one. Looking at a 45, 45, 90. I'm trying to take a little pause because I know that some of us are playing catch up. For a 45, 45, 90, the two sides have to be the same. If the angle across from it is the same, then the length of the side would be the same. For the hypotenuse, it is actually x, so whatever the length of the sides are, times square root of 2. So that means that 1 must equal x square root of 2. Divide by square root of 2 to get x. For those of you that do not know, Control C, if you hold down Control C, that will copy. And then, oops, sorry, Maya, that was supposed to be to everyone. And Control V is paste. So if you're wondering how I copy and paste so fast, I think most people know, but I know that there may be a couple that do not. It is quicker than having to highlight and right click, especially if you're using a trackpad. I don't know about you, but when I use that Chromebook, I get pretty frustrated at the trackpad. All right, now this is where I annotate a little bit. It is not common to keep the radical in the denominator. So we want to rationalize. So if you recall from topic 5 in algebra 2, that was the January, February time frame, we rationalize denominators. Okay, so 1 over square root of 2. It's not proper to leave the radical in the bottom. So to get rid of it, what we're going to do is multiply the top and the bottom by that radical. So in this case, square root of 2. Why can I do this mathematically? Well, this is something divided by itself, which is always 1. And I can multiply anything by the number 1 and still get itself back, even if it looks a little different. So like 1 times square root of 2 is square root of 2. Square root of 2 times square root of 2 is square root of 4. And the square root of 4 is just 2. So now I no longer have something in, or a radical in the denominator. So x equals square root of 2 over 2. And that's what we're going to put in our little text boxes here. Remember, if one side is that, so is the others. Okay. All right, so there's really only a couple of numbers that you need to know. There is 1, the square root of 3 over 2, and 1/2, and square root of 2 over 2. And that is it. Everything else is repeated when we get to going on this. All right, I'm taking a picture for attendance to make sure that I don't forget any of you all are on here. Okay, moving on. So when you go to this next slide here, you have some triangles. Words are very hard for me today, I'm sorry. What we're gonna do is take a second and I'm going to copy and paste into these triangles. I'm not gonna copy and paste the whole thing because the triangles are different sizes. But just to remind me what the height, and you don't have to have them right in those boxes. So like if that box covers it up, just bring it down a little bit. That's cool. Also, something I forgot to say in the beginning is if you are working dual screen, which I actually do recommend, there's a shortcut on your Chromebook where you can put like the zoom on the left side and what you're working on the right side, or opposite, doesn't matter. If you do Alt plus a bracket and then do the other bracket for the other thing, and it'll split your screen for you so that you can watch what I do and work. You may have to put your listening ears on extra though, because I know it does make your screen a little smaller, which means it's a little harder to read. All right, so my side's there, square root of 2 over 2. I don't know why I didn't copy this twice, but I didn't, so now I gotta do it again. Okay, I think I have all my measurements. So here's something new to most people is how to group, okay? So what I need to do is select one of my images. I'm gonna hold down the shift key. So hold down shift, and it will allow me to click all 3 of those pieces. So the 2 sides and the triangle. Then, if I do it correctly, which that was not, if I right click, I have the option to group. There's also a shortcut there, Command Option G, that will group it as well. So what does grouping do? Whenever I slide one, everything goes with it so that my side, the measurements of my sides will go with it. So it's as if you wrote on top of it, okay? So I'm gonna do that for each of my triangles. I promise I'm not trying to go to that other slide that it keeps doing. Okay. So when you are finished, they should group together and float like this. How are we doing on pacing? How far behind, caught up, completely lost? Help me out. You can send it to me privately. You don't have to send it to the whole group. No news is good news, hopefully. Fingers crossed. Okay, so this circle is what is called the unit circle. If you just Google unit circle, these are made for you. I could have easily done that, said, here it is. But I like to actually build it to give you some I like to give you some context, because if I just handed it to you and said, here, do with it, it seems made up. It seems that it comes out of nowhere, that someone just put it there for nothing. And it's all math based. It's actually a lot of geometry on top of trig. For some of you, that is a good thing. For others, you're like, oh no, geometry. So we are going to build our own unit circle. The unit circle, so the really big thing that we need to get from it, the unit circle has a radius of 1, hence a unit, no S, circle. Means it has a radius of 1. So let's use some of our logic. If this is 0, 0 on an XY plane, so you're talking about x-axis, y-axis, and this is 0, 0, what must where the circle and the x-axis meet right here be, if it has a radius of 1? So I'm not going to put these dots on everyone, because they're a pain to have to try to center correctly. But imagine that at each of these, so maybe I will, I don't know, we'll see. If you don't, I totally understand why. But imagine that there's a point at the end of each of those, okay? If it has a radius of 1, that means it went 1 over to get right there. So that means that on an XY graph, like on Desmos or something, I would have to be at 1, 0. Yes? Do we see what I was saying now? If that's the case, where's this? Zero, 1. All right. And on the left, I'm where? So over here, I'm at I have one person participating. Is everybody else asleep? What are we doing? So where am I at here? -1. I think I have to make this smaller. This was something that I tried to fix and it didn't fix for you guys, so sorry. All right, -1, 0. All right. And then the bottom one must be 0, -1. And you can get as picky as you want as far as your perfection tendencies and sizing and whatnot. All right. So next, I want to talk about what type of coordinates are in each quadrant. So what I mean is, what type of numbers are in quadrant 1? Like all numbers are what? If I have to go over right and then, so I go right and up, I'm talking about all positive numbers, right? This is true no matter what I graph. What about in quadrant 2? What's true about all the numbers that I graph? Yes, they are, well, we do X and then Y. So X would be negative, Y would be positive in quadrant 2. What about quadrant 3? Should be negative, negative, which means that quadrant 4, all my numbers will be positive, negative. Okay. Now, on a graph, so I opened up, you don't have to open up Desmos. I just want to show you something. If I am looking on just a regular graph and I am looking at the point, just making something up here, okay, 4, 1. That means that I went over to the right 4, so the length is 4 and the height is 2, right? So to get that point, it's over 4 and up 2. So if I'm looking back here and I want to know what the point would be at the end of this triangle, okay, it would have to be the length and the height, meaning that it would have to be square root of 2 comma square root of 2. Does that make sense? Kind of, sort of. So anytime I have a point, so let's go back to Desmos here. It doesn't matter what it is. So if I move it over here, it means that I go to the right 3 and up 1. So I can actually even make my own type of right triangle there if I really think about it. Okay, so the length and the height. So the same has to be true here, except I just have a different looking number. I have square root of 2 over 2 as my length and my height to be that point right there, which is what I'm wanting, is what is that point? And so I have labeled that point right there. Okay. Next, I want you to select your grouped object and hit Format Options. This should pop up. And we are going to flip it horizontally so that it is going the other way. Apparently it just selected. Okay. So for the time being, I'm not really worried about my numbers. I'll get them all back together later at the end. Just remember what your length and your height is, like your width and your height. Okay. So if you get it right away, that's awesome. But I'll get it back to normal once we go all the way around the board. Oh, wait, something I forgot to do. So I'm going to hit the undo button here until I go back to my normal flip. I want to not click next slide, please. Okay. To draw a line. So to draw a line, I'm going to click line, and I clicked it twice, so it undid it. And then I'm going to draw from the origin to the end. I want to make my line thicker so I can see, and I want to make my line blue. So if you missed any of those, this right here is a line. Draw it. Make your line thicker. I don't really care how thick you make it. That's up to you. I just like that measurement from when I did it yesterday. And then I made it blue. If you would rather make it a darker blue, that's fine. But the blue reminds me that it goes with the blue triangle. And now, after I've done that, I will flip. And go to this side. So if you missed flipping, format options, flip. Before I forget, I'm going to make the line the first thing I do. Oh, no, not that. Insert a line. All right. Now, again, I have a length of square root of 2 over 2 and a height of square root of 2 over 2. However, this time, I'm not going positive, positive. I am going negative, positive. So that means I'm going to have a negative square root of 2 over 2. And then a positive square root of 2 over 2. Okay. I'm going to flip again, except this time I'm going to flip vertically. Notice that the width or the flat side always stays connected to the x-axis. So every time I move this, it's still staying. That same leg is never leaving the x-axis. Also notice it now creates a straight line or a diameter all the way across the circle with the first piece that I drew. So this is a straight line now. This time I'm at negative, negative. Still same width, same height, but this time they're in the negative, negative area. Do it one last time. So flip horizontally again so that I'm right here. I was not trying to draw a text box, but I did click text box, my bad. So the good news is that if you were drawing this by hand and you messed up, you would have to start all over. With the use of technology, there's the undo button. So just trying to look on some bright sides there. Okay, again, the width and height is square root of 2 over 2. I just need to follow that this whole quadrant is positive and then negative. Okay. And now when I flipped it back up, it is all right side up. The world is grand. I just need to label my angles. So what I'm going to do is take this here. I like to make it size 20 because I did terrible formatting on that. That's what I thought I fixed when I asked you if you saw those orange squares and you told me no at the beginning. I thought I fixed all this formatting, so I apologize that we're having to do it again. But we agreed that the angle right here connected to the x-axis was 45 degrees because it was a 45, 45, 90, right? So every time we're talking about this, we're talking from the initial to the terminal, what's that angle, okay? So we can also knock out some of our easy ones. So if I am right here on the x-axis, there's two spots, two measurements that I'm at. What are they? So remember, it could be 0 or 360, depending if you're at the very beginning or all the way around. Another easy one, where am I at if I'm up here? I'm at 90. Where am I at here? $180. Where am I at here? I am at, anyone? Oh, that's not what I meant. I meant to do 20 here. There we go. All right, so 0 or 360, 90 degrees, 180, 270. And I've been asked to slow down, so I'm going to give a second to pause so that you can play catch up. A lot of unit circles have the points all the way around. I probably should have done that, but I did not. So if you want to be a little extra, you are welcome to make points. All I did was insert circle. But where it's so little, it's really annoying to fool with, as you can see. Just know that every point that we are discussing, so like every time that we fill in a point here, I'm talking about where the line that we draw and the circle connect. If you are looking ahead, I'm going to do pink next. I'm going to give you about 1 more minute. Because if I do not get to this last part, then your target does not make sense. So I want to make sure to get to the last part. All right, so we're going to repeat all of the things that we have done, meaning I'm going to draw a line at the 30 degrees here. This time I'm going to make my line pink because I'm dealing with my pink triangle. This time my width is square root of 3 over 2 and my height is 1/2. So width is square root of 3 over 2. And my height is 1/2. We are in the first quadrant, so it is positive, positive. Okay. If I still have my menu button over here. If you never did get that figured out how to open it, you went to Format Options. And then the first one there, and then Flip. Okay. I'm going to do the same idea here. Line that is pink. We didn't finish our blue degrees, but we will do them all together at the end to finish that up. Okay. Again, my width or my X value will be square root of 3 over 2, but it's in a negative direction because it was going left from 0. But the height is still a positive 1/2. I flipped vertically this time. Gonna do the same thing. Notice I did not take the width, so the long side, off of the x-axis. Every time I flipped it, it's still on the x-axis. That is actually something that people typically mess up in the classroom, and then they have to start all over again because they turn their triangle the wrong way. So hopefully you're less likely to do it digitally. Okay. And one more flip. Okay. I know that I'm not talking right away, but I'm just making those same lines, giving you a chance to work on it too. Yes, Sean, you can. I just want you to see the measurements here as to where we are getting those values. So in this one, it was still the width of negative square root of 3 over 2. And since we were going down, it's now at negative 1/2. The y value is negative 1/2 here, but it's positive square root of 3 over 2. So if you see Sean comment, he says, can't you just copy the lines and flip them? Yes, absolutely. I was just doing it this way so that you can see the triangles where we're getting those lines from. And it's from the 30, 60, 90 triangle. Okay, process of elimination. I'm sure you know what comes next, yes? So yellow comes next. We are going to do the same idea. What I want to stress here is that it switches. So now my width is 1/2 and my height is square root of 3 over 2. So X and Y flipped. Okay. I'm still going to draw my line. I make mine the gold color because that highlighter yellow I have a hard time seeing. And then I flip horizontally, go over here. Click 1,000 buttons before I get to the one that I actually want. Not really. I mean, yes, really, but that's not what I'm trying to do. I just happen to be doing that. And this time I'm at -1/2, +3 square root of 2. So I feel like I should be like playing music in the background or something while we work. Right, I have my 4 lines. The width for all of them were 1/2. Here they were both negative. And here it was positive, then negative. And then I can delete all the extras there. And I am almost finished making my unit circle. There are 2 last things that I need to do. I need to give all the lines measurements, which I've started, but I did not finish. So that's what we're going to do next. And then, so you can keep pulling from the corner here because that's what I meant for you to do. But since it's such poor formatting, you could actually make yourself one like this and just keep copying and pasting that one instead, so that it works a little nicer. Okay, so what is my first special angle there? So what was that pink angle that from, it's not 0, it's not 45, what's it gonna be? If you have not done 3.1 or 3.2 notes, you may be struggling with comprehension much more than others. What is this angle right here? So you have to see my mouse here. What is that angle? From the x-axis to that first pink line. Yes, 30 degrees. And so I'm just making sure that I can tell that that goes with the pink line. All right. So what is the yellow line going to be that's between 45 and 90 that was a special angle that we had talked about? So we talked about 45, 45, 90. We talked about 30, yeah, 60, 90. Oops, that 60 should be on the other side. All right. So we're gonna fill out this circle all the way around until we get back to 360 because a full circle is 360. So this is 90 degrees. So what is this yellow line that is 30 degrees past 90 and 60 degrees shy of 180? So 30 degrees past 90, 60 degrees shy of 180. Should be pretty easy math that I'm asking. Yep, 120. Okay, the blue was 45 degrees. So what is 45 degrees past 90 or 45 degrees shy of 180? Same number. Yep. Okay. And what is 60 degrees past 90 or 30 degrees shy of 180? Yes, 150. So all I'm doing is going around and labeling. If you're a little behind, that's okay. It's just the pattern. Critically think about, well, what does it have to be? So that same pattern, what is 30 degrees past 180? We could also say 60 degrees shy of 270. So 30 degrees past 180 is 210. $45 degrees past 280, or sorry, 180. So 180 plus 45 is 225. 30 degrees shy of 270 is 240. $30 degrees past 270 is 300. Now we're getting it. 45 degrees past 275 or 45 degrees before 360. Is 315. And last but not least is 330. Okay. So now I'm going to highlight all of that and delete it from my unit circle. You do not have to clean this up. This is just what I'm doing while you guys are playing catch up. All right. The last thing is converting all of these to radians. So if we had all of the time in the world, we would just, so zero is easy. 0 times anything is 0, so it's 0 radians. But like if I'm looking at 30 degrees, remember I times that by pi over 180, which means that I need to reduce the fraction 30 over 180, which means that it could be 3 over 18, which what does 3 over 18 reduce to? 1/6. So the radian here is 1 pi, which it's not necessary to put the 1 there, over 6. Okay. So that is the radian of the pink. So a radian is just another way to measure it. So if you have not done your 3.1 notes yet, that could be mind-boggling. We measure temperature in Celsius or degree. We can measure an angle in degree or radians. Okay, so that's the idea there. And I just converted from degree to radian. Okay. I know that there are a lot of reasons to be mad and bitter at virtual school. Many of those are very valid. I'm not saying that they're not. But one thing that you can be happy of, yes, there is something to be happy of, is if we were in normal school where I could watch you take a quiz, you would have to memorize this entire unit circle and take a quiz over it. But because of our virtual world, that's obviously hard as a teacher to monitor. So therefore, you get away with not having to do it. So thank you, virtual. Okay, going all the way around the circle is 2 pi. So I'm doing all the easy ones here. 180 is equal to pi. Then you can actually start thinking about it as like pi pieces, right? So if I were to take this away for a second, so there is the complete everything, right? And this is 1/6 of this whole thing, meaning that I can make 6 of those. 1, 2, 3, 4, 5, 6 of those. Okay. That's 1/6. That would have to be 2/6 of the pi, but what is 2/6 reduced? One-third, right? 2/6 is 1/3. Okay, just like 3/6 is 1/2. 4/6 is 2/3. And then the pink one down here would be 5/6. And then the 45s, there's 1, 2, 3, 4 sections of 45s. So that means that to get to the first one would be pi over 4, because it's 1/4 of what is showing there. I'm going to end up deleting that box, by the way. So if you're trying to make a box too, you don't have to. All right. And then this is 2/4 of the pi, which is 1/2. This would be 3/4 of the pi. Right, and so we have our first 2 quadrants finished of radians. Okay, I'm going to leave the rest of it for you to finish because I need to come back and actually talk about the super big ideas here that to help you finish your target for the day. So sine theta, So I'm inserting a special character here. I'm going to make that font bigger too. Give me just a second. So I have sine theta, and you're like, uh-oh, what? So remember, sine theta, if you did your 3.2 notes, was equal to opposite over hypotenuse, right? But if so moving my triangle over here, if I think about my opposite, it's this one right here, and my hypotenuse is 1. So for the unit circle, it is always equal to your x value over 1. No, not your x value, sorry. Height is y, which equals just your y value. So what does that mean? Okay, so if you're doing something different, make sure you're listening, because I'm just going to go through a ton of examples here. If I say, hey, what is sine of 30 degrees? You're going to look at the y value and say, sine of 30 degrees is 1/2. What is sine of 135 degrees? Sine of 135 degrees is square root of 2 over 2. What is sine of 3 pi over 2? Here's 3 pi over 2. Sine is the y value, which is -1. Okay. So does that make sense what I'm saying? So everywhere here, the y value is sine. So every y value is sine. For cosine, that equals adjacent over hypotenuse, which in this one, all the triangles we did, was the width over 1, because that's the adjacent. So that would be the x over 1, which is just x, because we don't ever have to say divided by 1, right? So if Miss Reidner asks you, what is cosine of 225? You find 225, you tell me the x value. Okay. Tangent theta is opposite over adjacent. So that is, the opposite is your y value, because it's your height, and your adjacent is your width. So it's y divided by x. Some of them are really easy, like what is tangent of 360 degrees? Well, y divided by x is 0 divided by 1, which is 0. Believe it or not, all of the tangents for the intervals of 45 degrees are easy as well, because what is anything divided by itself? Anything divided by itself is 1. So tangent here is 1. This one's easy but tricky. Y divided by x is 1 divided by 0. But remember, I can never divide by 0. So I actually say that it is undefined. Okay, so tangent of 90 degrees is undefined. Okay. So what does this mean for their reciprocals that we talked about in 4.2? It means that cosecant theta is equal to 1 over y. Secant theta is equal to 1 over x. I'm just writing them down first, and then I'm going to talk about them, so you'll have a chance to write it. Cotangent equals x over y. So remember, those three functions are reciprocal functions, meaning whatever your answer was up here, so it was y, the answer down here is the reciprocal. Now, some people get really confused because they try to put 1 over 2 square root of 3 because they're flipping a value. Don't do that. Just flip the fraction itself. So, for instance, here, cosecant of 60 degrees is going to be 2 over square root of 3 because I just flipped that fraction for the reciprocal. Okay. All right, so that is the big idea. How does that fit here? Let's finish this last page up to let you guys go. There are things called even and odd trig functions. Here's what that means. An even function means that even if it's negative, the answer is still the same as if it were positive. If it were negative, or if it's an odd function, it means that it's going to be whatever you thought the answer would be, but negative. So the only one that is even is cosine. So what that means here is cosine of 60, or sorry, cosine of negative 60 is the same thing as cosine of 60 because it's even. Okay. I'm going to be honest with you. I always forgot about these functions and which one was which. So what I would do is look at my unit circle. Here I am at 0. If I go negative 60, I'm right there because remember 60 is in a clockwise position. So then I would just state that cosine there is 1/2. Okay, so this one would equal 1/2 because cosine of 60 is 1/2. Also, because 300 degrees is coterminal. So if you got really good at coterminal, doing that coterminal puzzle, you could think of it that way. If I'm at negative 60 degrees, I'm really right here on the graph. That one looks like 45. So I'm really right here. What is the X value there? So quicker we get these 4 done, the quicker you all get to go. But I want answers from you. For sine, I'm going to help you out first. It is an odd function, so it's going to be the same as negative sine of pi over 2. So what that means is you need to tell me what sine of pi over 2 is. So go back to the unit circle. So go to the previous slide. Sine is the y value. What is the y value at pi over 2? We're getting some answers in. Yes, so it is 1, but since it's an odd function and I'm trying to find the negative, the final answer is -1. So let's up my font size so that you guys can actually see it here. All right, what about tangent of negative pi? So it is also odd. So that means that it's going to be equal to negative tangent of pi. Whoops. So I need you to go to pi. Tell me what y divided by x is. So at pi, y divided by x is 0 divided by -1. Very good. Which would be 0. But remember, right? So 0 divided by -1, which is equal to -0. But is that a thing? No, it's just 0. Okay, so the negative and the positive for tangent were the same. But if you think about that from a coterminal perspective, pi is right here. Negative pi is right there. So I'm at the same spot. So it makes sense that it's the same answer. Okay. Last one. Cotangent of -11 pi over 2. Is 11 pi over 2 on the unit circle? It is not. It is way bigger. So if I think about 11 halves, that's 5.5 pi. And the unit circle only goes around to 2 pi. So I need to figure out what is it coterminal to. So I'm going to keep adding 2 pi to that. So -11 over 2 plus 2. So -11 plus 12 is just pi over 2, right? And so now what I'm actually trying to find, so that we can get off of here because you have had enough math for one day, is cotangent of pi over 2. So if I go to pi over 2, did I do that wrong? Hold on. I feel like the answer was 3 pi over 2. Okay, pi over 2. Would be x divided by y. 0 divided by 1 is 0. Okay, you are finished. Finish your 4-question target. It should be, if somewhat simple, like there's no super in-depth questions, as long as you kind of got what was going on here. Stay on for any questions. So if something was not cleared up, you may stay on. But everybody else who's like, okay, I'm done, peace out. See you later.